basic thing about momentum, and that's conservation of momentum. That's kind of the key thing that gets us through these collision problems. Don't forget conservation of momentum. What that means is that in any closed system where there's no outside forces, the total amount of initial momentum before something happens, like a collision, is going to equal the total amount of momentum after the event. Pi equals Pf. Now, if we really wanted to, we could add a sigma there, which means add up the momentum before, and we can add a sigma there, which means add up the momentum afterwards. So we just have to make sure we are consistent with that. Well, let's just take the initial case of a really simple collision. And here's what we're going to do. We're going to just start out with, say, a box like this. And I'm going to make the mass of that box be, oh, I don't know, 3 kilograms. Great. And I'm going to have it sliding along the ground with no friction. It's important to have it be no friction here. We'll have it be sliding along, and we'll have its velocity be, let's say the velocity here is 20 meters per second. Good. Then I'm going to get another box, and I'll have that other box over here. And just to keep things easy, we'll keep the mass of that box also 3 kilograms. And we're going to start out with the velocity of this box being 0. Just to keep it kind of nice and easy, right? So that's the situation to start out with. 3 kilogram box at 20 meters per second sliding into another 3 kilogram box at 0. And of course we want to find out how fast are they going afterwards. So what I might do is I might draw a little double arrow like this, which means later in time something's going to happen. They're going to collide. And then I want them to stick together. And that's the idea behind an inelastic collision, is that they're going to stick. And what I'm curious about is, what's this final velocity right here, right? So actually really easy problem to do. We just need to add up the momentum before and the momentum after and find out what that is. So let's say all the initial momentum. All right, well, I've got the first box. That's 3 kilograms times 20 meters per second. And I've got the second box, which is 3 kilograms times 0 meters per second. Great. So that's pretty easy. Then I've got my final momentum, Pf. And since the boxes are stuck together, I've got 6 kilograms added together times my final velocity, Vf. What I really want to do is equate those two things together. So we'll just write it out in an equation. And I'm going to just write it out all in one line, and then we just have to solve for Vf. It's actually really easy. What I'm going to do here is I'm going to drop my units just to make it a little easier to work with, so I don't have to keep track of all the units. I know they're going to work out. So what I'm going to get is 3 times 20 plus 0 equals 6 Vf. Now we just solve this. 60 equals 6 Vf. So Vf is 10 meters per second. Which intuitively that should make some sense. Let's go back up and look at what the problem is. I've got a 3 kilogram, oh, that erased it. I've got a 3 kilogram box, and it's colliding with another 3 kilogram box. And it should make sense that that 3 kilogram box and that 3 kilogram box are going to collide and split the speed in between them. If I start out with 20 meters per second right there, it seems like they're going to split the speed in between them, right? Well, let's move on and let's do another example. And this time we will do a more general example. So we can just kind of get a general equation for this, right? So how do we go general? Well, you're very good at thinking in abstract terms. So instead of actually giving this a number, I'm going to call this M1. And it's going to be moving at a certain speed. Let me just draw a line across here so we know that we're done with that other problem. And this speed is going to be a general speed, so I'm going to call it V1 initial. V1 initial, right? It's going to be moving towards and colliding with another box. That one's going to be M2. And this box is also going to have a velocity. It's going to have V2 initial. Now, of course, one thing we know is that that velocity has to be less than that velocity, otherwise they're not going to collide, right? So that's just something that we need to realize and remember. It doesn't really matter for the equations, though. So then, once again, what's going to happen is some later time, I draw a double arrow like that. At some later time, they're going to have collided together and stick. So M1, and here's M2, and now what I just have is VF, just like that, since they're stuck together. Now we're going to write this conservation of momentum equation. It's going to look like this. I'm going to add up all the initial momentum, and I'm going to set it equal to adding up all the final momentum. And I'm just going to write an equation for it all. And it'll be a very, very general equation, right? So here's how my general equation is going to go. All the initial momentum is M1 V1 initial plus M2 V2 initial. Now it equals, the other side is the final momentum. And I'm going to write M1 plus M2 times V final. And that should work out, right? This is a general formula now for two objects that are going to collide and have an inelastic collision. That is, they're going to stick together. This is the general formula for it. So let's try it out. Let's just do one other example. Let's say I've got a box right here, and I'll say its mass is 5 kilograms. I'm going to make this guy going at 4 meters per second. And it's going to collide and stick to another box. Let's say this guy has a mass of 3 kilograms, right? And let's say it has an initial speed of 2 meters per second. So from this one, it's actually kind of challenging. It's not so intuitive to say, yeah, what's the speed afterwards going to be? So the original problem was easy. This problem is a little more tricky. Let's just go ahead and plug it into our formula right here for inelastic collisions. And here's what it's going to look like. My M1 is 5 kilograms times my V1, 4 meters per second, plus M2, 3 kilograms times 2 meters per second. That's going to equal M1 plus M2, that's 8 kilograms, and VF is what I'm looking for, right? Now we just have to solve this. And solving it's, not that hard, it's just algebra from this point. Let's see what we get. Once again, I'm going to drop my units here, right? So if I drop my units, then I'm going to get 20 plus 6 equals 8 VF. Now I was trying to work this out so the numbers were good, but it didn't work out that well. 26, so VF is 26 over 8, right? Okay, so now we got to do some mental math here. I know that's going to be 3, and I'm going to get 2 eighths left out of it. And an eighth is 0.125, so it's actually 2 eighths is a quarter, right? So that's going to be 3.25 meters per second. There's my answer. So that's how fast they're going after they collide. 3.25 meters per second. Once again, it's not so clear looking at that initial velocity and that initial velocity. What's the final velocity going to be? So there you go. Important thing is looking at this formula right here and seeing that it's a general formula for two objects that are going to have an inelastic collision.